Welcome to this comprehensive guide on C Action and Func delegates, essential tools for flexible and dynamic programming. In this tutorial, we'll demystify these powerful concepts, showing you how to treat methods as variables. We'll explore practical examples in both Visual Studio and Unity 3D, making these advanced topics accessible for absolute beginners. At its core, a delegate in C# is a type-safe way to represent a reference to a method. Think of it as a contract that specifies the exact signature, including parameters and return type, that any method must adhere to if it wants to be referenced by this delegate. This type safety is crucial as it ensures that the method being called always matches the expected signature, preventing runtime errors and improving code reliability. Delegates are incredibly useful because they allow you to pass methods as arguments to other methods, enabling highly flexible and dynamic code structures. Action and Func are predefined delegate types in C#, saving you the effort of manually defining your own custom delegate types. Let's start with Action, a delegate specifically designed for methods that take 0 or more input parameters but do not return any value, meaning they have a void return type. The syntax is straightforward. Action, T1, T2, for methods with parameters, or simply action if there are no parameters. Here's a simple console application example, an action delegate that takes no parameters and prints a message. You can also define an action that accepts one or more parameters, like this example printing a custom message. For multiple parameters, an action can perform operations such as calculating and printing a sum. Action is ideal for methods that perform an operation or trigger an event without needing to return a specific result. Now, let's see action in action within Unity 3D, creating a scenario where a character can perform a jump. We declare an action delegate named onJump within our character script. Next, we define the actual jump method, which contains the logic for the character's jump behavior. We then subscribe our jump method to the onJump action, typically in the start or onEnable method, and remember to unsubscribe and onDisable to prevent memory leaks. Finally, we invoke the onJump action when the player presses the spacebar, triggering the subscribed jump method. This setup allows for easy modification of jump behavior without altering the core input logic, showcasing action's flexibility. Moving on to Func, this delegate is used for methods that take 0 or more input parameters and, crucially, return a value. The syntax is func, T1, T2, tResult, where tResult specifies the type of the return value. In Visual Studio, a func delegate can take two integers and return their sum, as shown here. Func can also be used for methods that take no parameters but still return a value, like retrieving a name. Func is perfect for methods that perform calculations, retrieve data, or evaluate conditions, always providing a result. Let's apply Func in Unity 3D to calculate the distance of a game object from the player. We declare a Func delegate getDistance that takes a transform and returns a float. Then, we define the calculateDistance method, which computes the vector 3 distance between two transforms. We subscribe calculateDistance to getDistance in start and unsubscribe and onDisable. In a separate script, we can then easily retrieve and log the distance from the player using our getDistance func. This demonstrates how Func allows you to change calculation methods without modifying the core game logic. Lambda expressions provide a concise shorthand for creating anonymous methods, making Action and Func even more streamlined. For an action, a lambda simplifies the message printing example significantly. Similarly, for Func, the sum calculation becomes much more compact and readable with a lambda expression. Lambda expressions are particularly useful for simple, inline methods, enhancing code clarity and reducing boilerplate. Always check if an action or func delegate is null before invoking it to prevent null reference exceptions. Remember to unsubscribe methods from delegates when they are no longer needed to avoid memory leaks and unexpected behavior. Use action for methods that perform actions and func for methods that return values to improve code readability and maintainability. Consider delegates for event handling and callback mechanisms to create more flexible and decoupled code architectures. In summary, action is for void methods, func is for methods with return values, and lambda expressions offer concise syntax. We encourage you to experiment with Action and Func in your own C# projects to truly grasp their power and versatility. Thank you for watching this tutorial. If you found this guide helpful, please subscribe for more C# programming insights and tips.